Hi, everybody. If you're watching this video, you have finished this step where you picked your translation and your dilation rule. You have written in function notation form on your spreadsheet, and you have performed the operations on your points, and you have already clicked submit. So your spreadsheet looks like this. So now you're ready to do the math to prove the properties of a dilation. So in another video, we did the properties of a translation. We have to prove that the slopes are the same. So let's take a look at the steps. Step 1, you are going to pick 2 points on your new domain for this transformation. 2, you're going to find the slope. All right. Now, also the goal is to also prove that the ratio is equivalent to your chosen scale factor. So that's the second goal. Let me not leave that out. That is the second goal. So we can actually perform these 2 things at the same time. And then you have a third goal that we will do in a different video. So for the second goal, you're going to actually prove that the ratio is equivalent to your chosen scale factor. For me, my chosen scale factor was 1/3. So we're going to prove that mine is equal to 1/3. The work that I do is equal to 1/3. And I am going to take it step by step. So first, I'm going to pick 2 points. Then I'm going to find the slope and the distance for the 2 line segments that are created. Then I'm going to identify the corresponding points on the image. Okay. Find the slope and the distance of the corresponding line segment. And then use slope to show that the corresponding sides are parallel. So unlike translation where it's doing pre-image to image, we're actually doing pre-image to pre-image and then image to image. And we'll explain that in just a moment. All right, so here we go. I'm just gonna stick with E and F, okay? So I'm just gonna stick with E and F. So that makes these 2 points the points that I'm going to deal with, okay? And then the corresponding points on the pre-image would be here. That's because translation comes before dilation for me, all right? For you, it might be different. You might switch them around. But for me, translation comes first and then dilation. So I'm going to use EF here and I'm going to use EF here for my corresponding points, okay? And I'm going to flip back and forth because I'm not going to remember these numbers. So here we go. The other thing you can do, and I should have did this earlier, is you can take a picture of your points so you don't have to keep flipping back and forth. Okay? You can take a picture of your points so you do not have to keep flipping back and forth. This is our dilation work. Okay, and remember we got to prove that the lines are parallel. So that means the slopes are the same for parallel lines. Okay, so that's one thing we got to prove. We also got to check the distance. The distance is equal to the scale factor. So I'm checking to see if it's equal to my scale factor. My K was 1/3. So you got to make sure it's equal to your K. All right. You might choose something simple like the number 2 or 4 or 5, whatever. I chose 1/3 being all difficult and stuff. Okay. So my point, once again, and I just forgot it. So pre-image. And then image, just make sure. All right. And remember we're doing E and E prime, F and F prime is what I decided to do. Okay. All right. So now I took a picture of my point so I won't have to flip back because I knew I was not going to remember it. So my pre-image is -6, 1.25. and -5, 1.4. My image for dilation is -2, and 0.4167. I'm going to do it like that, and negative 1.67. I'm going to round it, and 0.0467. All right, so those are my points. Okay, so of my pre-image, I'm going to find the slope and distance on my pre-image. So to find the slope, y1 minus y2 over x1 minus x2. To find the distance, it is the square root of x1 minus x2 plus squared plus y1 minus y2, and square that as well. Okay, if you prefer to use the Pythagorean theorem, then use the Pythagorean theorem. That will also get you the distance, whatever works for you. All right, so the slope is going to be, let's label our points, x1, y1, x2, y2. And so 1.25 minus 1.4 over negative 6 minus a negative 5. And we're going to figure out the slope there. Okay, to figure out the distance, remember to, right, you're plugging in, or substituting is the correct word for it. All right, so x1 is going to be negative 6, right? x2 is going to be negative 5. And y1 is going to be 1.25. And y2 is going to be 1.4. And then for the sake of time, I'm not going to work it out, but that's how you set up the problem. I'll do the same thing over here. Find the slope and distance of the image. Let's do that in a different color. So x1, y1, just making sure you understand how to do this. And you're going to compare when you're done. So x1, so y1 rather, I should say, 0.4167 minus 0.467, and negative 2 minus a negative 1.67. So find the slope. You're going to compare this number to this number to see if it's the same. If it's the same, then the lines are parallel. All right, now let's look at the distance. All right, so the distance is going to be here. Okay, so we're going to do x1, which is negative 2, minus x2, which is negative 1.67, and y1, which is a decimal, and I'm going to need more room, right? Decimal, and I'm going to need more room. 0.4167 minus 0.467. All right, so once I get those two numbers, so I get the answer here, okay, and I get the answer here, I am going to, like you've seen before us do last week, you are going to take the image distance so that's in blue. You're going to take that number, and you're going to take the pre-image distance, and you are going to divide those. And it's got to be equal to K. You're checking to see, and so for me, I would be checking to see if it was equal to 1/3.